Welcome back. Myself Tapan Rai and my channel is Fun with Physics. In my last class, we have discussed the Bohr-Sommerfeld atomic model, and in these chapters we have already discussed the Bohr's theory, its drawback, the Bohr's correspondence principles, magnetic moment, Larmor frequency, Larmor precision. Today we are going to discuss the Sommerfeld extension of Bohr's theory. So basically the question is arising here, why this theory is needed? Why? Is there any extra benefits here? Yes, obviously there is extra benefit. That's why we are going to discuss this theory. According to Bohr's theory, each spectral line of a hydrogen atom must be a single line, or that is a single frequency. But later Sommerfeld and the other Michelson and other, they told this is not so. Why this is not so? They told that for each energy levels of different quantum number of an hydrogen atom must be split into different energy levels. This phenomenon is not explained by the Bohr's theory. That's why this theory is needed. So in Bohr's theory, according to Bohr's theory, the concept of the electron is revolving around a circular path. See, in Bohr's theory, the energy levels is like that. This is energy levels E1, this is energy level E2 for different quantum number. But according to Michelson and the Sommerfeld, this energy level will be split into sub-level, right? This is the sub-level of slightly different frequencies and energies. Okay, that's why Sommerfeld come and he introduced the concept of the elliptical orbit, right? So then Sommerfeld, right? Then Sommerfeld introduced the concept of elliptical orbit, right? Elliptical orbit. Okay, to explain this, in elliptical orbit, according to Bohr's theory, electron is revolving around a circular path, but in case of Sommerfeld, the electron is revolving around the elliptical paths with one of its nucleus at the focus, right? So the picture will be like that. So this is the elliptical path, right here, and in elliptical orbit there are two axes. One is the semi-major axis and other is the semi-minor axis, right? So this is semi-major axis, this is semi-minor axis, right? So this is A and this is B, and nucleus is one of its focus. So this is the nucleus, right? And suppose this is electron, and this electrons is revolving in this path, right? So let's see, at that point, okay, at that point the velocity of the electron will be at the tangent. This is tangent, and also the momentum here, right? So this is the distance between the nucleus and the electron. Now if we see the motion of the electron on its plane, the velocity or the momentum has the two components, right? So one is along the radial part. So this is the radial part, okay, and this is the azimuthal part, and the radial part is the p suffix r and the azimuthal part is the p suffix theta, right? So now we know what is the radial velocity. Now radial velocity, radial velocity v suffix r is equal to dr by dt is equal to r dot, right? And v theta is equal to r into omega. R into what is omega? Omega equal to d theta by dt. D theta by dt is equal to r. What is d theta by dt? R theta dot. This is theta dot, right? Now, so Sommerfeld assumed the generalized quantum condition. Okay, Sommerfeld assumed the generalized quantum condition to describe it. So what is the generalized quantum condition? The generalized quantum condition is P suffix R into dr equal to N suffix R into H, right? And another is the closed integration P suffix theta into d theta is equal to K into H, right? So this is equation number 1 and this is equation number 2, right? What is NR? What is K? Here where N suffix R is equal to radial quantum number, right? Radial quantum number, right? And K is the azimuthal quantum number, right? Now let's see what is PR here. PR is equal to M into V. What is V? V means R dot. So here M into R dot is equal to M into dr by dt. Okay, what is P theta? Here P theta is equal to M into V into R is equal to, what is V? V means omega into R, M into omega into R is equal to M into R square into omega. What is omega? Omega means theta dot. So here also theta dot, right? Now under the central force P theta is equal to constant. Okay, now from this equation number 2, this P theta will be outside integration. So here P theta is outside integration and close integration into d theta, limit 0 to 2 pi, okay, equal to K into H. If we integrate d theta, we will get here P theta is equal into theta over the limit 0 to 2 pi equal to K into H, or P theta into 2 pi is equal to K into H, or P theta is equal to KH by 2 pi, right? Okay, now from equation number 1, what is equation number 1? Closed integration P suffix R into dr is equal to N suffix R into H. Okay, what is P suffix R? P suffix R means M into R dot, right? So here M into R dot means dr by dt. So here dr by dt into dr, right? Into dr is equal to N suffix R into H. Okay, now see from these equations, closed integration M into dr by dt. So here dr by dt into dr, right, equal to N R into H. Let's see here also M into here dr by d theta. This d theta is extra, so we need another d theta in the numerator. So it is d theta, right? And this is dt, this is dt, this is dr. So we need another d theta. This is extra, so another d theta here, right? So here also nr into H. Now let's see here M into what is dr? This is dr by d theta. This is also dr d theta, so this will be whole square. So d theta by dt means theta dot. Here also theta dot into d theta is equal to nr into H. Okay, so now this is M into theta dot into dr by d theta our whole square into d theta is equal to nr into H. Okay, now we multiply here r square and divide by r square, right? So here also M into theta dot into r square into 1 by r dr by d theta whole square into d theta. So here also, what is m theta dot into r square? M theta dot into r square means p theta, right? So integration p theta into 1 by r dr by d theta are equal to whole square into d theta is equal to nr into h. Okay. Now we know the equation of ellipse, right? The equation of ellipse of eccentricity. Now the equation of ellipse of the eccentricity, what is the equation of the ellipse of this eccentricity? Now the equation of ellipse of eccentricity is equal to r is equal to a into 1 minus epsilon square by 1 plus epsilon into cos theta, right? So we need this. So dr by d theta is equal to a into 1 minus epsilon square into 1 plus epsilon cos theta, right? If we solve it, and here also epsilon cos theta, and the derivative of the cos theta is minus sin theta. This is minus sin theta, and for this there should be minus 1 into epsilon, right? So this is epsilon, this is minus 1, this minus minus plus. So ultimately dr by d theta is equal to a into 1 minus epsilon square into epsilon sin theta by 1 plus epsilon cos theta whole square. Okay, now see what is the value of r. Here r means a into 1 minus epsilon square by 1 plus epsilon cos theta. So put here, right? Now we have to evaluate the following integrations. What are the integrations? Closed integrations p into theta, p suffix theta, right? So here 1 by r dr by d theta whole square into d theta is equal to nr into h. Okay, now let's see, this is dr by d theta, okay, and this is r, a into 1 minus epsilon square by 1 plus epsilon into cos theta, this is r. So another part is here 1 plus epsilon into cos theta, right, into epsilon into sin theta, right? So from these equations, this 1 by r, this is 1 by r into dr by d theta is equal to epsilon sin theta by 1 plus epsilon cos theta. Okay, so this should be, and this value will be put here, right? So closed integrations p theta, right, into what is the value of this? Value is here epsilon sin theta by 1 plus epsilon into cos theta into d theta into nr into h. So as this is square, so here will be square part, right? So this is square and this is also square, right? Now we have to evaluate these integrations, standard integrations. So now let u is equal to epsilon sin theta, right, and v is equal to 1 by 1 plus epsilon into cos theta, right? So using the standard equation integration by parts, u into dv is equal to uv, right, into minus integration v into du. So here closed integrations, right, uv, what is u? U means epsilon, epsilon into sin theta. So epsilon into sin theta. What is v? V means 1 by 1 plus epsilon cos theta. So 1 by epsilon into cos theta, right? Limit will be 0 to into 2 pi, right, minus close integrations into 0 to 2 pi, right, by 1 by 1 plus epsilon cos theta into d theta. Okay, so here also p theta, this is integration I equal to nr into h cut. Now p theta, so this part will be 0, so this is 0. Why 0? Because this is sin theta, so theta means 2 pi, so this will be 0, right? So minus integration 0 to 2 pi 1 plus 1 epsilon into cos theta into d theta. Okay, this can be written as like that into p theta, right? So integration 0 to 2 pi 1 plus epsilon cos theta minus 1 into d theta, right? Now if we evaluate this integration, we'll get p theta into 2 pi, right? Into 2 pi, and after that 1 by 1 minus epsilon square. So after solving this integration, okay, minus 1. So last first is the here. So this is nr into h into p theta 2 pi, and this is right. So what is the value of the p theta? Now the value of the p theta is kh by 2 pi. So we'll put here. So now nr into h is equal to p theta means k into h by 2 pi into 2 pi, right, into 1 by square root 1 minus epsilon square minus 1. 2 pi is cancelled, right? So nr into h is equal to k into h is also cancelled, into 1 by root over 1 minus epsilon square minus 1. Okay, so nr by k is equal to 1 by square root 1 minus epsilon square minus 1. So from these equations, nr plus 1 by k is equal to 1 by 1 minus epsilon square. So this is the final equations, okay, for Bohr-Sommerfeld model, in Sommerfeld model, and let nr plus k by LCM equal to k is equal to 1 by 1 minus epsilon square. So put nr plus k is equal to n, where n is the total quantum number, right? So n by k is equal to 1 by 1 minus epsilon square is equal to a by b, right? This is the equations. Now k by n is equal to b by a, as b greater than, this is the most important formula, okay, to this elliptical motions. And now if as a much greater than b, as a greater than b, so from these equations this is less than 1, right? So k by n less than 1, this implies that n greater than k, right? So this is the condition of the quantization of the different elliptical orbit, right? And now we know n is equal to nr plus k, okay? Now for different values of k and nr, we will get the elliptical shape here. Now see, for value of k, now let's see, remember the potential value of the k, the potential value of the k is equal to 1 2 3 dot dot dot, and it is not 0, k not equal to 0. Why k not equal to 0? Because we know p theta is equal to kh by 2 pi. If k is 0, then this part will be 0, and then p theta is 0, and electron will execute the simple harmonic motion, so it is not possible, right? So k not equal to 0, and the permissible values of the k is equal to 1 2 3, it is right. Now for different value of n, right, let n is equal to 3, right? N is equal to 3. From this, suppose k is equal to 3, so for n equal to 3, k is equal to 2, so nr is equal to 0, right? And if it is so, then k by n is equal to 1, right, or k is equal to n, and this will define the circular motion, right? And for k equal to 2, the shape of the elliptical is like that, and for k is equal to 1 is like that, okay? So